Once again, welcome to my vlog. Our topic for today is all about integration of rational functions leading to partial fractions. Okay, so what do you mean by this topic? This topic focuses on the rational functions right here. We have our rational functions nx over dx, and then this type of rational function is a proper fractions. So when we say proper fractions, the degree of the numerator is lesser than the degree of the denominator. So if we have x raised to the power of n minus 1 for the numerator, and we have x raised to the power of n for the denominator. So we'll consider this one as a proper fractions. Okay. So what is instilled in this topic? This topic, nx over dx, could be done and could be solved using the previous method. This could be solved by the inverse trigo method. This could also be solved via trigonometric substitution. But we will be having this topic in order for us to easily solve the given rational functions. So these rational functions that we're talking has different forms depending upon the denominator. So we have 4 cases right here: case 1, case 2, case 3, and case 4 depending on the denominator. If our dx is a distinct linear factors, then that is instilled in case number 1. For example, if we have the denominator of x plus 1, x plus 2, so distinct linear factors. Case number 2, if our denominator is repeated linear factors. So if we have x plus 1 squared, this is now considered as a linear factor repeated. And case number 3, dx is a quadratic factor if our denominator is in a form of quadratic equation. So let's have x squared plus 2x plus 1, or we could also have x squared plus 1. This is now considered as a quadratic factor. So if the denominator is in a form of quadratic, then therefore it is part of case number 3. And we have case number 4, repeated quadratic factors. If we have this one, x squared plus 2x plus 1 squared. Okay, so we'll focus on whatever our denominator is. If we have a denominator just like this, that is linear, this that is repeated linear, this one that is quadratic, and this one that is repeated quadratic, belongs to case 1, case 2, case 3, and case 4. Okay, so let's discuss first what does it mean when we are dealing with partial fractions. Okay, so this is a rational function. We have nx over dx. The method that we're going to do is the method of partial fractions. We are going to decompose this one. We're going to find its equivalent value. Okay, decompose rational functions or the partial fraction decomposition. This is the result after we apply partial fractions. So let's have an example. 5 over x minus 2 and multiplied with x plus 3. So this is our rational function. Notice we could decompose this one in terms of, we have an unknown value over x minus 2 plus an unknown value over x plus 3. Okay, this is what we called as the partial fraction decomposition. Okay, this is equivalent to this one, but unfortunately we don't know what is the coefficient for the numerator for this item right here and what is the numerator for this item right here. So this is an unknown. Basically what we're going to do, we are going to assign value of a constant. Let's call this one as A and let's call this one as B. and so on and so forth. Okay. So now let's have this example. Example number 2. We have an nx, the numerator, and look at our denominator. X minus 1, x plus 1 squared, x squared plus 1. Okay. This is equivalent to, we have the following. A over x minus 1 for this denominator, for this factor. We have b over x plus 1 for this repeated factor. So this repeated factor, since it is squared, it has two values. So we have x plus 1 plus c over the x plus 1 squared. Okay, so there are two values here. We have x plus 1 and we have the x plus 1 squared, since this is a repeated factor. And the last one, dx plus e over x squared plus 1. Why do we have two letters right here? Because this is now a linear form and our denominator is a quadratic form. So here's the guide. If we have a linear in the denominator, this one, the numerator will be constant. Okay, and if we have quadratic for the denominator, we have quadratic, the numerator will be linear, just like this one. So this is a linear, this is a quadratic, constant, linear, constant, linear, constant, linear. This is specific equivalent values. Okay, so we will be using this method, this rational function converted into partial fraction decomposed form. From this one, we will be finding this one. From this one, we will be finding this one. Since our topic is integration, so if you have an integration for this rational function, and if it is equivalent to this one, then we also have an integration to this part right here. If we have an integration in this rational function, okay, and it has equivalents just like this, and we also have the individual integral of the following. Okay, so this is a new method in finding the values of our, or in finding the integration of our rational functions. But before that, let's have the guidelines. Okay, these are the guidelines. So guidelines for solving basic equation. There are two types, linear factor and quadratic factor. Case number 1 is a linear factor. Case number 2 is also a linear factor. Case number 3, quadratic factor, and case number 4 is also quadratic factor. So for the linear factors, substitute the roots of the distinct linear factors in the basic equation. So we could use our calculator to find the roots or find the values of x based on our linear equations. Number 2, for the repeated factors, use the coefficients determined in the first guideline here, what we have found in number 1, to rewrite the basic equation, then substitute the other convenient value for x and solve for the remaining values of the coefficient. So that is the first guideline, or the first part considering linear factors. The second part is the quadratic factors. Okay, so what shall we do? Number 1, expand the basic equation. If we have already find the basic equation, we will be expanding. Number 2, collect the terms according to powers. Number 3, evaluate the coefficient, the like powers, to obtain a system of linear equation involving A, B, C, and so on. And number 4, solve the system of linear equations. Please follow the guidelines for you to easily solve the problem. Okay, so now let's begin with example on case number 1. Okay, case number 1, for distinct linear factors, we have the integral of 1 over x squared minus 5x plus 6d of x. Actually, you could solve this problem via inverse trigo or via trigonometric substitution. But this time we will try to solve this one by using partial fractions. So first, let's try to take this algebraic term right here, 1 over x squared minus 5x plus 6. Okay, that will be equivalent to, okay, notice we could factor our denominator, x squared minus 5x plus 6. So this is equivalent to x minus 3 and x plus 2. So I will erase this one and rewrite the equivalent value, x minus 3 and x minus 2. Okay, again, this is from the denominator right here. So we now have two values for our decomposed form, x minus 3 and x minus 2. Okay, or you could write x minus 2 here and x minus 3. It doesn't matter which place are you going to put, as long as it is separated. Now you don't know yet the coefficient, so we will assign value. Let's have a for the constant of this item right here, or this fraction right here, and we will also use b for this fraction right here. Let's write the basic equation. What is the basic equation? Multiplying everything with the denominator of the original function. What is the denominator? We have x minus 3, x minus 2. Multiply this one to the original function, or the original rational function. We will be having a result of 1, since this is its denominator. Multiplying this one to the first term. So notice we have a x minus 3, x minus 2 over x minus 3. We could cancel this one, and we have also to multiply this one to the second term, x minus 3, x minus 2 over x minus 2. Notice we could cancel this one. We now have a x minus 2 plus b x minus 3. This is what we called as the basic equation. Let's go back to the guideline. Okay, for linear factors, substitute the roots of the distinct linear factors in the basic equation. This is our basic equation. Let's try to substitute the roots. Okay, what is the root here? X equals to 2. What is the root here? X is equals to 3. Okay, so we will be substituting the roots. First, so we will be declaring what is the value of the root, x equals to 2. What would happen? 1, a, 2 minus 2 plus b, 2 minus 3. So a will be 0, 2 minus 2 is 0, times a, that is 0. So we now have b, 2 minus 3, we have negative 1. Okay, so negative b. Therefore, the value of b is negative 1. Okay, the other value of the root, when x is equivalent to 3. So we have 1, a, 3 minus 2 plus b, 3 minus 3. 3 minus 3, that is 0. B is 0, therefore the value of a, 3 minus 2 is 1. Okay. Now that we have found the values of a and b, we will substitute it to our original. Okay, we will substitute it to our decomposed partial fraction form. Okay, so we now have an equivalent value integral of a, which is 1, over x minus 3 dx, plus the b, which is negative 1, over the denominator x minus 2 dx. So this form right here is equivalent to this one, since we have the algebraic solution right here. So this is basically equivalent to integral of dx over x minus 3 negative. So we'll factor that one out, negative integral of dx over x minus 2. Okay. So if we consider u as x minus 3, the du is obviously dx right here. And if we consider u as x minus 2 for this part right here, the derivative of u, we have the dx, the numerator. So we now have the form of du over u minus integral of du over u. That is ln of u minus ln of u plus c. We have different u's here. So let's try to substitute. The u here is x minus 3. ln and the u here is x minus 2 plus c. We have solved case number 1. Okay, so let's evaluate this one for the case 2. Okay, so notice we have our rational function right here, and take a good look upon the denominator. So obviously we could factor out x. So let's get the algebraic term. 5x squared plus 20x plus 6 whole over with, if we factor out x, this will be x squared plus 2x plus 1. Notice we could factor our denominator again. 5x squared plus 20x plus 6 whole over with x. This could be factored with x plus 1 squared. Okay, so this has an equivalent value with a over the denominator x. We have a repeated linear factor, so we'll write first b over the x plus 1, and then the repeated one, c over x plus 1 squared. Okay, what shall we do? We're going to find the basic equation by multiplying the denominator of the original functions. We have x and we have x plus 1 squared. Multiply this one to the original. Let's denote the equal sign. We now have 5x squared. Copying this one, we will cancel. 5x squared plus 20x plus 6, that is equivalent to a with x plus 1 squared plus, if we multiply this one to b, we have bx, and we'll cancel one value of the x plus 1, x plus 1 plus c. If we multiply this term right here to this term, we will cancel x plus 1 squared, so we now have cx. Okay, so this is our basic equation. Okay, for repeated factors, use the coefficient determined in the first guideline. So we will use first the substitution of the roots. What are the roots? So notice here the roots are 0 and negative 1. The roots. X is 0 and x is negative 1. Okay, let's try to substitute the roots. Okay, let's use first 0. Okay, so when x is 0, 0, 0, so what's left on the other side of the equation? We have 6 a 0 plus 1 squared plus b times 0, 0 plus 1 plus c times 0. This will be 0. This would also be 0. So 6 is equivalent to A. Okay, understand? So we have to take note upon the equivalent values. So 0, 0, we now have A equals to 6. Now the next root, when x is negative 1. So we have 5 negative 1 squared plus 20 negative 1 plus 6 equals to ax. All the x is negative 1. Negative 1 plus 1 squared plus b negative 1 negative 1 plus 1 c negative 1. In this side of the equation, this is 0. Negative 1 plus 1, 0. This is also negative 1 plus 1, 0. So we have negative c. Okay. While on the other side, we have 5 minus 20 plus 6. Okay. So 5 minus 5 plus 6 is 11. Positive 11 plus 20, we have negative 9. Negative c. Therefore, c is equivalent to 9. Okay. So now that we have the values of a and c, let's go back to the guidelines. Substitute the other convenient value of x and solve for the remaining value of the coefficient. What is the unknown coefficient? We already have the value of a and we have also the value of c. We need to solve the value of b by substituting any value of x. So let's try when x is equivalent to 1. We already have when x is 0, when x is negative 1. Let's choose when x equals to 1, considering the value of a as 6 and the value of c as 9. Okay, so let's have this side of the equation. Okay, 1 squared plus 20 1 plus 6 equals to a 1 plus 1 squared plus b times 1 plus 1 plus c times 1. Okay, so let's start it here first. So we have 5 plus 6 11 plus 20, we have 31. We have the value of a 6 and we have 2 squared. We have b times 2 plus 9. Okay, so 6 times 2, 6 squared, we have 2 squared, we have 4. 4 times 6, we have 24. 2b plus 9. Okay, so we have 24 plus 9 as 33. Okay, so we have 33 transposed to the other side. So 31 minus 33, we have negative 2. Okay, dividing both sides with 2, we have b as negative 1. So we now have the values of a, b, and c. So let's use these values A is 6, B is -1, and C is 9. Let's erase this part first. We've known already the process. This one is equivalent to integral of A, which is 6 over x dx, plus integral of B, which is -1 over x plus 1 dx, plus C, which is 9 over x plus 1 squared dx. Factor out all the constants. 6 integral of dx over x, negative dx over x plus 1, plus 9 integral of dx over x plus 1 squared. U as x, the derivative of the u dx. U as x plus 1, the derivative of the u is dx. U as x plus 1, the derivative of the u is dx. We now have the form 6 du over u plus 9, and we have u squared du. Okay, so this is 6 integral of u, 6 ln u minus ln u plus 9 u to the -1 over -1 plus c. Notice this is u raised to the power of -1 because we can rewrite this one u -2 du. Okay, now let's substitute the values of our u right here. 6 ln x minus ln of x plus 1, negative negative, so negative positive, so we have -9 over, we have x plus 1 plus c. This will be our final answer. Okay, so case number 3, we have the integral of 2x cubed minus 4x minus 8 whole over with quantity x squared minus x multiplied to quantity x squared plus 4 dx. And let's have the algebraic process first. Using partial fraction, we have 2x cubed minus 4x minus 8 all over with, as you can see, this part right here, we could factor out x. We now have x minus 1, we have x squared plus 4. So this could be equivalent to, we have a linear, so the numerator should be coefficient over x plus a linear over x minus 1, and we have quadratic, so AB cx plus d over x squared plus 4. Let's multiply the value of the denominator with x, x minus 1, and x squared plus 4. Multiplying this one to the original function, we have 2x cubed minus 4x minus 8. And we have a with x minus 1 and x squared plus 4 plus b with x and x squared plus 4 plus cx plus d multiplied with x and x minus 1. Okay, notice in our guidelines for quadratic factors, expand the basic equation. This is our basic equation. We will be expanding this one. So we'll be having 2x cubed minus 4x minus 8. Okay, so the expansion of this term right here, maybe I'll just have this as is a x squared plus 4 minus a x squared plus 4 So I have here plus b x cubed plus 4x c. I'm going to separate cx squared with x minus 1 plus dx of x minus 1. So let's proceed. 2x cubed minus 4x minus 8. A, we have x cubed plus 4x minus a x squared plus 4 plus b x cubed plus 4x plus c x cubed minus x squared plus d x squared minus x. Okay, so what I did is just I've distributed this part right here to this part right here, this part right here to this x, this part right here to cx and to d. Okay, now we're going to collect the terms according to power. Okay, so according to power. So which term has cube? So the coefficient that has power. So 2x cubed minus 4x minus 8. For the cube, we have a, there's no other cube, plus b, we have the cube plus c. This is the cube. Next, for the square, we have negative a. So I'll just have negative a squared minus c, and we still have plus d. So these are the squared. But for the x, plus all the x, I have 4a and I have 4b. Okay, 4a and 4b. And for the x, I have minus d. And lastly, for the constant, plus the constants, negative 4a, the constant, so 4a, only 4a, so this is minus 4a. Now what shall we do? Equate the coefficients of the like powers to obtain a system of linear equations involving ABC. So I'm going to equate the right side to the left side. Okay. So for the coefficients of x cubed, this side was x cubed 2, and here a plus b plus c. The coefficients of x squared. There's no x squared in this side of the equation, that is 0. And we have negative a, negative c plus d. The coefficients of x. Negative 4, how about here? 4a plus 4b minus d. And for the constant, we have negative 8. No constant, we have the constant. Equals to negative 4a. We could now find the value of a. over negative 4 over negative 4, a is 2. We could also have the values of a here, 2 plus b plus c, negative 2 minus c plus d. And we have 4 times 2 plus 4b minus d. Transpose 0 equals to b plus c. Here we have positive 2, negative c plus d. And here we have 8, and we have negative 12. 4b minus d. We have equation 1, equation 2, equation 3. We already have the value of a. For equations 1, 2, and 3, we could use our calculator, mode, system of linear equations. So system of linear equation with 3 unknowns. Use mode. We don't have a calculator here, so just use mode, and then you would substitute values for the coefficients of b 1, coefficients of c 1, and coefficients of d 0, and the constant is also 0. Coefficient of b is 0, coefficient of c negative 1, coefficient of d 1, and the constant 2. We have coefficient of b 4, coefficient of c 0, and we also have negative d. And we could find the values immediately, the values of b, c, and d. For b, it is 2, negative 2. For c, that is positive 2. And for d, that is positive 4. Okay, so these are the values obtained using our calculator. Okay, so we now have the value of a, which is 2, the value of b, negative 2, the value of c, 2, and the value of d, which is 4. Okay, using our calculators. Dx. Okay. This could be also written as 2 integral of dx over x minus 2 integral of dx over x minus 1 plus, we could split this one. Okay, so we have 2x over x squared plus 4 plus 4 over x squared plus 4 dx. So 2 integral of dx over x, 2 integral of dx over x minus 1 plus 2x x squared plus 4 dx plus 4 integral of dx over x squared plus 4. This is the u, x, the du, dx, the u, x minus 1, the du is dx, the u is x squared plus 4, the du 2x dx, so let's write this one again inside. Here we could use inverse trigo. Let's have a squared, 4, a is 2. Okay, the u squared is x squared, the u is x, the derivative of u is dx. We now have the form 2 integral of du over u minus 2 integral of another du over u plus here we have another du over u plus 4 integral of dx is du, x squared, that is u squared, 4, that is a squared. This belongs to arctangent. Recall arctan. This one is 2 ln u, 2 ln u plus ln u plus 4 1 over a arctan of u over a plus c. 2, what is our ln u? The u here is x, negative 2, ln the u here is x minus 1, ln the u here is x squared plus 4 plus 4, what is our a? Our a is 2, so 4 divided by 2 is 2. The arctan of the u, it's x over a 2 plus c. This will be our final answer. Okay, next item. Let's solve for the quadratic factors. Repeated. Case number 4. Let's have 8x cubed plus 13x whole over with the quantity x squared plus 2 raised to the power of 2. So let's take the algebraic expression or the rational function. We have 8x cubed plus 13x whole over with x squared plus 2 squared. This is a quadratic equation and it is repeated. So we'll have ax plus b, a linear numerator over a denominator of quadratic, x squared plus 2, plus another linear numerator, cx plus d over x squared plus 2 squared. Okay, the same process we did from the linear for repeated linear. Okay, multiply with x squared plus 2 squared, the denominator. Multiply it here, we now have 8x cubed plus 13x. Multiplying it here, ax plus b with x squared plus 2. And we have cx plus d. This one will just cancel the denominator. Okay. Again, according to the guidelines, we will be expanding this one. So we have 8x cubed plus 13x equals to, separating this one with a and b, ax x squared plus 2 plus b x squared plus 2 plus cx plus d. 8x cubed plus 13x, a, distribute inside the x cubed plus 2x plus b x squared plus 2 plus cx plus d. Okay, equating coefficients. Coefficient of x cubed. On this side we have 8. On this side we have x cubed. We have a. Therefore, we already have the value of a, which is 8. Now, the coefficient of x squared. Which one has x squared? B. Here is 0. 0 on this part right here. B. No other x squared. So b is 0. Okay. And let's have the coefficients of x. On this part right here, we have 13. Okay. This is equivalent to 2a plus we have C. Okay, but we already have the value of A. 13, 2 times 8 plus C. 2 times 8 we have 16, 13 plus C. Transpose 13 minus 16 we have negative 3 is the value of our C. Okay, and let's have the constant. So for our constant, there's no constant in this side of the equation, 0, only x cubed and x, and we have the constant here, b, 2b plus d. We have constant d. b is 0, 2 times 0, therefore d is also equivalent to 0. So we only have values, we now have values a, b, c, and d. A is 8, b is 0, c is negative 3, and d is 0. Okay, so we already have the value. Equivalent, this one is equivalent to now integral of 8x plus 0 over x squared plus 2 dx plus integral of negative 3x plus 0 over x squared plus 2 squared dx. Okay, so this is equivalent to 8x. Let's write 8 outside, x dx over x squared plus 2. Let's try to write negative 3 outside as well. Integral of x dx whole over with x squared plus 2 squared. Okay, so how about this part right here? If we consider the denominator as the u, x squared plus 2, the derivative of u, 2x dx. We have already x dx. We need to find 2. So if we write 2 here, 4 times 2, that is 8. So we now have 2 and 4 outside. The form of du over u. Now solving for this integral right here, we could set the denominator as the u, x squared plus 2. The derivative of the u is 2x dx. So in order to have 2 here, I'm going to divide this one with 2 and multiply this one with 2. Okay, this is now the form of 4 integral of du over u minus 3 over 2 in the form of du over u squared. Du over u squared. Now let's evaluate. 4 ln of u minus 3 over 2. This is u raised to the power of negative 1 over negative 1. Again, we could rewrite this one as u raised to the power of negative 2 du. Okay, so we now have 4 ln of the u. The u here is x squared plus 2 minus 3 halves, negative negative, so this is plus 3 halves, 1 over the u here, which is x squared plus 2, plus c, of course, our final answer. Now evaluating integral of e to the x over the quantity e to the x minus 1 multiplied with the quantity of e to the x plus 4d of x. Now this method, since we haven't have an example of transcendental functions, we will convert this transcendental in terms of algebraic. So we let values, if we consider u as e to the x. The derivative of u is e to the x dx. So what would happen? All the e to the x will become u. And how about the numerator? So if you write dx right next to e to the x, that is du. We could now perform partial fraction. Partial fraction equivalent to this one. We have 1 over u minus 1, u plus 4. So that is a over u minus 1 plus b over u plus 4. Multiply with u minus 1 and u plus 4. We have 1, a with u plus 4, b with u minus 1. Substitute the roots. What are the roots? Using calculator, u is -4 and u is 1. So let's have when u is -4. One a -4 plus 4 plus b -4 minus 1. Cancel. This is 0. -4, -1, -5 b. Okay, so b is -1/5. How about the other root when u is equals to 1? Okay, we have 1 on this side of the equation. A 1 plus 4 plus b 1 minus 1. This is 0. 1 plus 4, 5. 5a, therefore our a is +1/5. Okay, so this will be equivalent to the decomposed form. A as 1/5 and b as -1/5. So integral of 1/5 dx over this is no longer dx, it's du. Du over u minus 1 minus 1/5 integral of du over u plus 4. If this is the u, so let's try another variable. Let's have v u minus 1, the integral of dv, we have du. Let's have v u plus 4, the derivative of v, still the du. 1 over 5 integral of dv over v minus 1 over 5 integral of dv over v. 1 over 5 ln of v minus 1 over 5 ln of v. What is the v? 1 over 5 ln of the v, it's u minus 1 minus 1 over 5 ln of the v, u plus 4. But this is still in terms of u. Our original function is in terms of e to the x, so let's bring back the values of the u, which is e to the equivalent to 1 over 5 ln of u is e to the x minus 1 minus 1 over 5 ln of e to the x plus 4 plus c. Okay, notice we could factor out 1 over 5. We now have ln of e to the x minus 1 minus ln of e to the x plus 4 plus c. The properties on ln of u minus ln of v, that is ln of u over v. So we now have 1 over 5 ln of, this will be the numerator, this will be the denominator. Let's see. That is our final answer.